Hey guys, this is the first video of 7. And so one of our learning goals this week is to finish the StatMedic software by taking a full AP exam. Now, notice on the software, that would have been the full AP exam had we done the class, had coronavirus not happened. So we have to prepare ourselves for an online exam. So that's what we're doing. So this week we're taking a full exam in the old format, and we're preparing for an open book at-home exam. So here's what I'll be looking for you to do. In each unit, you should create a one-page cheat sheet, and I will attach mine. You can kind of use mine, but you have to kind of produce. Maybe you like mine better than yours, but you do have to produce your own. And I'll explain how I produced this. Okay, so here's an example. Kayla gave me these documents for Unit 1. So, these videos here, this one, video 1.2. So in Unit 1, here were some of the answers for the free response question. And this is how it would have been graded. So essentially correct. So this is a lot of paper. So, a typical person for Unit 1 gave me anywhere from two to 4 pieces of paper, okay? So how would I compress that information and make it easy to reference? So I'm going to show you what I did. So on the first section here, type 1, in the video, they went over the types of displays. So let me just kind of zoom in here. They said that these are the types of displays: histogram, dot plot, box plot, and stem plot. So I put a small sample of some information. So there's 6 in this box, 3, 1, and 1 in that box. So if you're dealing with a histogram, step 1 is you're going to label the amount in the bars. So if those numbers are not inside the bars, you'll put them in there. And then you'll count up the total number to find out the total amount in that data set. So we see here that there were 11 items, whatever these are describing, 11 items in this histogram. Then to find the median, you're going to divide the total data set by 2. So we know that the median would fall between the number 5 and the number 6. So this is this first 6 people in the data set that have the lowest value. And so you know that the location between the number 5 and 6 would fall right in that bar. So on a histogram, that would be the location of the median. So that means we would locate which bar has the median in it. Okay, so what are some other ways we'd be able to see data? Well, we saw examples of dot plots. And again, you can just count the number of dots. That would be the total number in your data set. And that's one of the benefits of a box plot or a dot plot. What other kind of plots? Well, we see very commonly box plots, and you're more than likely going to see 2 box plots. A box plot is useful because it has a 5-number summary. Those numbers are the minimum and the maximum, quarter 1 and quarter 3, and the median. So what's happening in the box plot is each portion is containing 25% of the data, or you might also think of each piece being cut into quarters. So there's the bottom half of the data and the top half. The inner quartile range is the middle or center half of the data. Okay, so what are some little nuances here? If you see an asterisk above or below, that means that's an outlier. Now, what is the top of the bar? Well, if there isn't an outlier there, the top of the bar would be the max. But notice this would be the maximum value. So the top of the bar is the largest non-outlier number. This would also happen on the other end of the data. Okay, so the last type of plot you might see that has numbers, this is all quantitative data, right? Stem plots, is a back-to-back. These are also common, so I'm going to give you a couple tips. Both the data sets in this example are skewed right. So even though this one I can kind of turn and see how the data is skewed right, and here it looks like the data is skewed left. But remember, both data sets are skewed right because the one on the left is a mirror image. Another tip is you can treat, these are called leaves, this is the stem. You can treat the leaves like dots. So we can count up the leaves to figure out how many numbers are in the data set. Also, stem plots have a key because this is a type of symbology. So 2/2, in my example, I said this was how heavy cats were. So the heaviest cat was in the group on the right of 49 pounds, and the lightest cat was 11 pounds that was in the left-hand group. Notice both groups had a cat that was 22 pounds. All right, you see that? So that's how you read a stem plot. Now, the other things that are coming up in Unit 1 that would show up on your test especially is to describe a distribution, because this is a free response question and all your questions are free response. So we went over, you will have to describe SOCS plus context. Now, sometimes if one of the 4 items don't play a role, then for all 4 points, you have to get that context. So you're really shooting for 5 items to get full points. So many students have trouble like, well, when I talk about shape, what words do I use? So remember, it's either symmetrical, meaning I can fold it over and it mirrors on top of itself. Skewed to the right, meaning trailing off to the, skewed left, trails to the left. Skewed right, trails to the right. And also they'll be looking for you to use LY words. So we would say strongly skewed left or slightly skewed right. You use those words to describe how skewed it is. Now, the other thing that's important here is if data is symmetrical, then we will typically use the mean and the standard deviation to describe center and spread. If the data is skewed, then we choose median and IQR to talk about those measures of center and spread. You can also use range to talk about spread. Okay. Now, it doesn't come up on the test very often, but if you have to calculate the outliers, these would be the formulas for a value way too small or way too big. Also, I'll mention that mode is pretty much not used, but mode just means most, the number that happened the most frequently. All right, so I took these notes after watching videos and kind of condensing my other notes on a single piece of paper that's easier to make a reference. Okay, sorry about that noise, it was my clipboard. So I also took some more notes because when I got into the free response questions, I like this wording here. So let's talk about it. Here's some data I collected on number of hours of sleep. Now, if they ask me to describe this distribution, I want to make sure I get all my words in. So I want context. The distribution of the hours of sleep is slightly skewed left, see how it's trailing to the left, so I got my shape, with a median of 7, okay, that's how I'm talking about center, and a range of 5 hours, so 8 minus 3 is 5, with an outlier of 3 hours. That's full points. I got all my SOCS and my context. So what if I needed to do more with this data? Chapter 1 is called one variable statistics, right? One variable data. So I put this little symbol if I need help remembering what to do with my calculator. So my directions I wrote for myself are enter as a list. I want to hit home and list. I have to name the list. So I named it sleep. I got to type in the values, hit menu, stats calculations, one variable stats, and then I have to tell the first list that I need to name it sleep and hit OK. That's how I could get the calculator to calculate anything that I want. So I'm going to demonstrate that now with the calculator, and I would suggest practicing this. Okay, so let me escape out of here. I just did it a minute ago. You can see that I did it. So step 1, hit the house, right? And then find this list in spreadsheets. And name this, so I think I already named it, so I'm just going to call it sleepy, right? And here's my data. It looks like I have one person at 3, one person at 5, 2 people at 6, 4 people at 7, and 2 people at 8 hours of sleep. Okay, so these were the directions I wrote. I said hit menu, stats, stat calculations. There's my choice, one variable stats. I just have one list of data, so I'm going to, okay. And there's that X1 list. So I have to tell the calculator that I've named this Sleepy. So I'm just going to scroll down because it is alphabetical. So Sleepy. I called my data Sleepy, and now I'm going to hit OK. Notice the calculator will give me the number of data points, the minimum, quarter 1, median, quarter 3, maximum, and it will also give me the mean and the standard deviation. So it's pretty handy. Let's go up here. So my standard deviation is 1.5 and my mean is 6.4. This calculator did everything with my one variable stats. Okay. Now, what would be more likely? Well, we have to really soup up these free response questions. So more likely you'd be comparing two distributions. So here I made a quick sketch of corporation A and B and their salaries. I got that out of my notes. And I would want each of these pieces, context, shape, center, spread, and outliers. So the distribution of the two companies is my context, have similar unknown shapes. So sometimes on box plots, I can't really tell the shape. It looks like it's not really skewed left or right because these outliers might skew it both ways. With company A with a higher median, so this is the median, the center of the box, so this one looks a little bit higher. And you could say slightly higher. The range in IQR is greater for company A, so the range, max minus min, is definitely greater. IQR is the width of the box. So definitely the width of the box and the max minus min are both greater for company A. And company A has two outliers while company B does not. So I would give each piece. Also, here's some things to consider. So low spread means more predictable. So if you have to choose between two things, a lower spread in general just means more predictive. I know what I'm getting because it's less spread out. Higher values. So of course, higher values in general mean more money in this example, but that could just be two people that are getting more money. So again, you may want to pick a company that's more predictable. And again, options when you see two, no low values. So see how this company B has no low values. That would be a safer bet. Okay. Now, a couple other things come up in this chapter where we have to define the standard deviation. So in effect, a standard deviation is the typical amount a number in the data set is away from the mean. Technically, it's the average amount any number is from the mean, and so that's what it means. Another thing I wanted to point out in a multiple choice question, that bar graphs only show categorical data, which we'll see in a minute. So this looks like a bar graph, but it's not. It's a histogram because the bars are smushed together. Okay. This is a dot plot, right? Not a bar graph. All right. Variance. Another thing to point out, which will continue to come up, is standard deviation squared is what variance means. So they would have units squared. All right, now a common question on stats exams is having to make some calculations if some data is missing from averages. So there was a question in Unit 1 I thought that was important. The total amount of people is 12, but the average of 10 people was 156. So assume that those 10 all had a score of 156. So we just blanketly assume, even though we know they maybe didn't, but we assume that they all had that same score because that's what it means to have an average. Next, they gave us the other two score values. And so we can calculate the total scores of 12 people. And it also allows us to calculate the new average because if this is the total score of all 12, we can divide 12 from that. This came up over and over all year in multiple choice questions that I continued to put on the tests and the retests. Okay, so last but not least, in this section, we talk about categorical data. So categorical data means asking questions like what color eyes you have. So if we had two groups, a segmented bar graph would display one variable within two groups. You could go up to 3 or 4, but this is just an example. So I have asked girls and boys. So notice I'm finding the proportion. So the height of this segment is the height of the proportion that had blue eyes that were girls. And the height of this section is the proportion of boys that had blue eyes. So it should make sense that the height of a segmented bar graph is 100%, or all of the people are considered. Now, the fault of this is that you can't tell if more guys or girls were studied. And so to get a feel for this, we could, if there were twice as many girls than boys, we could double the width, and this is called a mosaic plot. So it's kind of a beefed up version of a segmented bar graph. Okay. So what is it that I'm asking you to do? Notice I took my condensed notes, which you're free to write on another piece of paper, and then I squished them on a single piece of paper. So you might want to do two things. You might want to do the same thing, condense your notes on a single piece of paper, or maybe do what I did, squish it on about 2 or 3 pieces, and then shrink it down using some kind of software. But no matter what, I've got one single piece of paper that I can reference, that I'm familiar with if I get a question on this subject for the AP exam.